So let's look at the equipment being used for this exercise. To start with, we've got a light box here, and we've got a narrow beam of light that's hitting this triangular prism, this 60-degree prism, and of course you can see some of the dispersion here. I'm going to adjust this so that I get a greater degree of dispersion. So hopefully you could see there that we're getting red and going to violet over here. And what I'm going to do now is trace the rays and trace around the prism so that I'll then be able to remove the prism and retrace where the rays are going. As carefully as I can, I'm going to place 2 dots in order to be able to say where this ray travelled from, where it went to. Over here with our dispersion, we've got red here, so I'll mark where the red is, and over here where the violet is. And what I need to do now is mark here on the paper where the light came out. And it actually comes out slightly different for the different colours, but I'm going to do this as best I can. And over on the other side where the ray went in, so now I can remove the prism and retrace where the rays went. And with a protractor, I'll mark our normal. And now I can measure the angle of refraction and the angle of incidence. So here is the angle of incidence, here is the angle of refraction. Here we've got our red light, and here blue or violet. Measuring these angles now, these two different or three different angles, this one here, and this one here, will enable me to work out the refractive index for red and the refractive index for violet. Now I'm just going to extend this ray here to make it easier to measure, and with a protractor work out the angle here, so that's 10, 20, 30, 40, looks like 41 degrees. And over here for the red, (10, 20, 30, 40, 50, 60, 70, 70, 76, and for blue or violet, (80), 1, 2, 3, 4, 5, 6, 7, 87. So now I can work out the refractive index for each of those colours.